Welcome to an example in which we're finding the LCM for a big group of numbers. For all those numbers, what's the LCM? Well, remember for LCM, what you have to do is step one, prime, well here, let's break down the numbers, down each number to the primes. Vertically line up the primes. Step 3, the LCM is the highest power for each prime. So that's how we always find LCMs. So I'm going to basically make a big chart here. I'm just going to start with a 3. And I'm going to say, okay, what's in a 3? Well, just 3. Next comes the 4. What's in a 4? Well, that's 2 squared. Right, I'm just going down this list. 3, 4, next comes 5. What's in a 5? Well, that's just 5. So notice how I'm lining up, I'm leaving space. Let me in fact show the spaces here. For 2, 3, 5. Let's keep going. What's the next one? 8. Now 8. Now if you need to do 8 on the side, go ahead and do it right over here. 2 times 4, 2 times 2. So you break down the 8. Notice it's 2 to the third power. So 2 to the third power. Next one is 9. What does 9 equal? You know what that equals, right? 3 to the second power, 3 times 3. 10. That's 2 times 5, isn't it? 12, and you might need to do 12. That's 3 times 4 and 2 times 2. So it's 2 2's and a 3. So 12 is 2 squared times 3. Good. Okay, 16. It's 4 times 4, 2 times 2, 2 times 2. 4 twos. We don't include the 4s because they broke down further, just like we didn't include the 4 there or there. So just the numbers that can't break down anymore, the primes. 4 twos. So 16 is 2 to the 4th. Two more numbers. 18. So if I do 18, that's 2 times 9, and 9 is 3 times 3. So we don't include the 9 because it broke down, just the numbers that couldn't break down, 2 and 2 3s. So 18 is a single 2 and 3 squared. Like that. Final number, 20. That's 4 times 5, and 4 is 2 times 2. We don't include the 4, just the 2 2's and the 5. So 20 is 2 squared times 5. Okay, so now, at the very bottom down here, we're going to do the LCM. So here we go. What is the LCM? So step 1, we broke down the numbers to primes. Step 2, we vertically lined up the primes. Step 3, the LCM is the highest power for each prime. So what's the highest power for the prime, this first prime, the prime of 2? What's the highest power you see there? It looks like 2 to the 4th. This one right here, huh? That's the most number of 2's any of those numbers has. Next come the 3's. As you look at the 3's column, what's the highest power you see there? 3 squared. Right, here and here. And when it comes to 5's, what's the highest power you see? Just a regular 5. I don't see any higher powers. So the LCM will equal 2 to the 4th times 3 squared times 5. Just use your calculator, right, and multiply those together. 2 times 2 times 2 times 2, 2 to the 4th. Or you can use the power button, times 3 times 3 times 5. So I'm getting 720. That's the LCM. What that means is that's the lowest number, least common multiple, that all these numbers will divide into. All these numbers, 3, 4, 5, 8, 9, 10, 12, 16, 18, 20, all of them divide evenly into 720. They'll go into it perfectly, and that's the lowest number they'll all go into. It's kind of weird we can find that, isn't it? That's the lowest number that all those numbers divide evenly into. It's the least common multiple, is what that is. Let's do one more. There's a second part on this question. let's a little bigger numbers. So let's start with, they're asking for the LCM of 15, 20, 24, 27, 30, 35, 30, 35, 36, 40. Okay, so let's write out these various numbers. We'll start with the 15. We gotta do the same thing we did last time, where we have a dividing line here, and then we'll have a little bit of space for each of the primes. I don't know how many we're going to need. It's probably plenty right there. Okay, and so we'll have 15 here, and then we'll 1, 2, 3, 4, 5, 6, 7, 8 of them. So second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, and then we'll have our answer. Okay, so let's do the 15 first off. 15, you know that's 3 times 5, so I'll go 3 times 5. Next comes the 20. What's in a 20? Let's go over here and break it down. 4 times 5, 2 times 2, 2, 2, 5. We don't use the 4, that broke down. 2, 2, 5. So 20 is 2 squared times 5. I'm just listing the various primes. So I did 15 and 20, 24 now. 24 is 4 times 6, that's 2 times 2, 2 times 3. So 3 2s and 3. We don't need the 4 and the 6 anymore. They broke down. 3 2s and a 3. So 24 is 3 2s and a 3. 27. Well, that's 3 times 9. Use your calculator if you're rusty on these. So 3 3s. We don't need the 9. He broke down. So 27 is 3 to the third power. 30. That's 3 times 10. 10 is 2 times 5. So 3, 2, 5 for 30. So 2, 3, 5 for 30. 35. Well, you know that one. That's just 5 times 7. 5 times 7. 36. Now 36, you might say, well, that's just 6 times 6. That's true, but 6s break down. They're not primes, right? 2 times 3, 2 times 3. So 2 2s and 2 3s. We don't need the 6s anymore. They broke down. They're not prime. So 2 2s, 2 squared, 3 squared, right, is 36. And last comes the 40. And so the 40, that's a 4 times 10, which is 2 2 and 2 5. Again, we don't need the 4 and the 10. 3 2s and a 5 for the 40. 3 2s and a 5. Okay, so we broke it all down. So now comes the LCM. And what is the LCM? You take the highest. It's kind of weird because it's called the least common multiple, but you take the highest power because that's a multiple of them. So look at the 2s. First off, what's the highest power? So it's the highest power for each prime. Highest power would be 2 to the third, right? Got that right here and right here. What's the highest powers on the 3s? Looks like 3 to the third. What's the highest power on the 5s? Well, it looks like just a single 5. And then on the 7s, a single 7. So we've got it. We have it. So what is it then? The LCM will equal 2 times 2 times 2, right? 2 to the third. Times 3 times 3 times 3, 3 to the third. Times 5 times 7. So what's that? I'm getting 7560. 7,560. That is the lowest number that all those numbers divide evenly into. Does that make sense, what we just found? So in other words, all these numbers, 15, 20, 24, 27, 30, 35, 36, and 40, all will divide evenly into 7,560. 7,560. All those numbers, if you divide any of those numbers, 7,560, by any of these numbers, they'll all go in perfectly evenly with no remainder. In other words, the 7,560 contains all their pieces. He's the lowest number that contains all their pieces. Just like 720 is the lowest number that contains all these guys' pieces. It's kind of like those Lego sets. I don't know if you've ever played with Lego sets or bought your children Lego sets. I've done both. And they give you like a bunch of pieces, and you can make different things. So now they're kind of specialized, but back in the olden days, they give you a bunch of pieces, and you can make different things out of those pieces. Well, that's pretty much what we're saying. If you want to make all these pieces, you want to make a 15, a 20, 24, 27, etc., you need 7,560. That's the lowest set that has all the pieces that can make all these numbers. All these pieces here are found in the 7,560. That's the least number that contains all these pieces to build those numbers. And on this one, the 720 is the smallest number, the lowest number that contains all the pieces needed to build all those numbers. That's what we're finding, the least common multiple. And how we do it is we break down each number to primes, vertically line them up, and for the LCM, you take the highest power, right? Because you need, like, to build a 16, you need 4 2s. So we got to put 4 2s in the set. To build, you need 3 2s for some of these sets, so we got to put 3 2s in the set. You need a 5 for some of these sets, so we got to put 4 2s, 2 3s, and a 5 for that number. And the other number, we had to have 3 2s, 3 3s, a 5, and a 7 to be able to build all those different numbers. That's least common.